Hello, YouTube universe. We are going to play again with the Raspberry Pi, but today I'm going to show you how to use Java code to actually turn on a LED. And that's why I've got this diagram up on my screen. This is a very simple wiring diagram that references the Raspberry Pi's GPIO, that's general purpose input-output pin array. And it shows you how to actually wire up an LED light, a very simple LED, a single LED light, to your Raspberry Pi. So if you take a close look at this diagram, you see we're making use of only two pins. We're making use of pin number 6, which we use for ground, and then that's the 6 that I'm referencing right here in this diagram. I don't believe that that's actually supposed to be referred to as pin number 6. It's this number 6 here in this particular diagram. So it's the 6th pin down from the top. Or the top right. So really technically it's the 3rd from the top right down. That's the ground. And then if you go down here a little bit more, this is GPIO 01, referenced as pin number 1, but it is the 12th pin on the array, which is referenced by this number right here. This pin is pin number 1. That's what we're going to be working with. This pin number 1 is going to actually turn on our LED. So based on this wiring diagram, and I'm no expert here on circuitry, but you want to make sure that you have a single LED that is connected to pin 1 with this 220 ohm resistor in between. Now if you take a look at what I've done, you see this is relatively crude. It's not the prettiest looking thing in the world, but I do have a breadboard, and a breadboard makes it a little bit easier because you can get away with putting this stuff together, you know, without twisting wires together and without having to worry about soldering or anything like that. So it's not the prettiest thing. I wish that my wires sort of matched the color of the wires that they're representing here in the wiring diagram, but I kind of had to scrounge around the house to get something working, and this is what I found. So basically what I've got is I've got my pin number 1 connected to my breadboard. I then connect this 220 ohm resistor to another array here, and then that's what I plug in the positive anode of the LED into. And then quite simply I've got the ground pin connected to an array on the breadboard, and that's what the negative pole of the LED light is plugged into. So very straightforward, even for a rookie like me to kind of get something together. So this is going to be something that's you've got to put this together. It's of course outside the scope of this particular tutorial. This tutorial is going to be focused on the code that you have to write to turn on this LED and how to get that code from a place where you've got it on your system and you're deploying it to the actual Raspberry Pi. That's what we're going to cover today. So what I'll do is I'll link to this wiring diagram here in the video description, and then when you get an opportunity, you definitely want to put something like this together so that you can follow along with this demonstration. So on that note, let's go ahead and get started. Okay, my first move is to go ahead and create a Java project, and I'll go ahead and do that. You've probably seen me do this before in previous tutorials. I'm going to make this a Maven project. And then the one thing that I just notice happens every single time I do this is I've got my recording software running, I've got my IntelliJ IDE running, then my computer will need to kind of heat up for a little bit. Fan starts to spin up. Of course, you'll probably hear that in the video if you're unlucky, and my apologies, that'll eventually kind of die down. So what I'll do is I'll just go ahead and give this a group, and I'll identify an artifact. We'll call this Pi4LED. That sounds good. And we'll leave the version as is. That'll just be something that we reference in the project as we move along. We're just going to call this Pi4LED as a project name, but I am going to change where I'm saving it. And then I'll finish that, and we'll move on. Directory doesn't exist. We'll create it. All right. And what that's going to do is it's going to go ahead and build my project, and we'll need just a couple of seconds for it to go ahead and finish its indexing and setting up the development environment. Okay, and with that completed, what I'm going to do is just go ahead and fast track this a little bit by taking what I know I need in my POM. POM is specific to a Maven project. That stands for Project Object Model. And I'm going to paste in the things that I know that I need. Of course, we're going to be leveraging Spring Boot to make this a little bit easier. So you see that I've referenced Spring Boot as my parent project, and then I've identified two dependencies. I want to get really close to my screen so I can show you what these are. This is, of course, the Spring Boot starter web dependency. This is what we're going to need to have in order to make sure that we expose some web services. And then the second dependency here is the actual Pi4J framework. Pi4J is the website that I was looking at initially to show you that wiring diagram. Pi4J is a Java framework that enables us to use an API to reach in to the pins on the GPIO and activate and deactivate them as needed to, use Java code to create our electrical components on the on the Raspberry Pi. So really cool stuff here. And then if you just follow the rest of this example, you've got all of the things that you need in order to actually do a Spring Boot Maven build. That's what this particular plugin component is. So I've got another video that kind of describes the basics of setting up a very simple Java application using Spring Boot. That's what I'm following here in order to kind of put this together. So I'll make sure to reference that in the video description as well. That's definitely something that you'll want to review to get started so that you know what we're putting together here. So this piece right here won't be the focus of what we're looking at. The focus is actually going to be the Java code that we're going to write. On that note, let's go ahead and we'll start writing some code. I want to first set myself up with some packages to organize my code. So let me do that now. I'll do com zonkware, and our project is called Pi4LED. So I'll create a package with that same name. And that's where I'm going to create my initial application class. The application class is important because it's going to start up our application. So I'll just call it application. That makes it a little bit simple. I'll remove these comments. I don't necessarily feel like I need those. So let me wrestle here with my formatting. So what I'm going to do is very simply, I'm going to create my public static void main method that you need in any sort of a Java application. If you've ever done Java development before, this will be very familiar to you. I'm going to create my public static void main. And just like any other Java application, if you've done one before, you're going to make sure you include an array of strings, which you call args. But this is where things get a little bit different. For the purposes of a Spring application, especially a Spring Boot application, what you want to do is you want to reference a static method on the Spring application class. That's this. And that's called run. You're going to send it 2 arguments. The first one is this actual class, and the second one are the args that you've allowed for in the argument, or I'm sorry, in this main method. And that's all you need to do to actually, that's all the Java code that you actually need to do to set this up as a Spring Boot application. The last and most important piece, of course, is to use an annotation called Spring Boot application. So that's going to have this actually run as a Spring Boot application. Again, this may seem foreign to you, so I definitely encourage you to refer back to a previous tutorial that I did on getting up and running with Spring Boot for a Spring MVC web application. It's very important that you look at that so that you know exactly what it is that we're putting together here. So as far as Spring Boot is concerned and setting up sort of the guts of the application, you're looking at it. This is all you're really going to have to do. The rest of the Java code that you're going to be working on is going to be focused on getting a controller up to reach into the GPIO on the Raspberry Pi and get that running. So let's do that now. I am going to create yet another package to keep my code organized. This one I'm going to call com.zonkware.pi4LED controller. That's where I'm going to put my controllers. In this particular case, however, what did I do? I created a class, excuse me. Let me try that again. Let's see if we can get it right this time. com.zonkware.pi4LED controller. All right, and what I was trying to tell you before I got distracted by my goof is that we're really only going to have one controller, but I still want to organize my code anyway. So we'll call this the LED controller. And that's that. I'll go ahead and remove my, I'll remove my comments here. I don't want those. And I'll wrestle again with my formatting, make sure that I've got that okay. All right. So what I want to do is I'm going to create a couple of methods here. I'm going to create 2 endpoints. The first is just to make sure that we're working correctly. So what I'll do is I'll create public string greeting. I won't include any arguments there. All I'm going to do is I'm going to return a string. and that string is going to be hello world. And that's just to make sure that once I get this application up and running, I can hit an endpoint and have it return a response. Of course, in order to do that, I need to make sure that I make use of an annotation, and that's request mapping. And I'm going to make sure that I specify that the path to get that is just the root. So when I fire up my application for the first time, I want to be able to go to just the root application and have it come back and tell me hello world. That's how I know that my application is going to be running on the Raspberry Pi and that I can expect the functionality that I'm anticipating. So I'll create my second method. This is going to be what turns on the light. So we'll call this light. And again, we won't give it any arguments, and I'll tell you why. We can pass arguments to the method and we can engage an on or an off. But what I want to do is I want to, instead of doing that, I want to actually leverage the toggle functionality in the GPIO API that Pi4J provides. So I'm going to toggle the light on or off every time I hit this endpoint. So I'm not going to worry about what methods I need to pass to this particular endpoint. I'm just going to say if this endpoint gets hit, toggle that light. If it's on, it'll go off. If it's off, it'll go on. So here's how we do that. We need to first get a handle on the actual GPIO controller. That is an actual class in this API, GPI controller. So that's what we're going to get. I will Alt-enter this. Oh, that's not working for me. Here, let me try this. I'll give it a name. GPIO controller is the class. I'll just call it GPIO for short. To get that, you don't actually get to call an instance of it. You actually need to leverage this factory. All right, I'm going to Alt-enter on these, and that's going to import them. So you'll see if you look up here at my imports, I've now imported the GPIO controller and the GPIO class. Get instance, it says it's not working. No, excuse me. I need the GPIO factory. All right, let me get rid of this. Okay, so what I've got is I've got the GPIO factory, and I'm leveraging the static method of getInstance on it, and that's going to return me an instance of the GPI controller, and that's what I need to get a handle on the actual pin. And what we want is we want pin number 1. Let me show you how to do that. So there is a class. It's called GPIO pin digital output. GPIO pin digital output, and I'm going to just call that pin. And to get a handle on the pin, we have to leverage that controller. There's a method on the controller. It's called GPIO. It's called provision digital output pin. Provision digital output pin. Kind of a long method. This is it takes a handful of arguments, and there's a different implementations of this particular method, and this is the one that we want. We want to first reference the actual pin itself, so the pin's name on the GPIO, and I'll show you how to do that. We want to give it a name, and then we want to identify the actual starting pin state, which can either be low or high. Low represents getting a handle on the pin with the pin not activated, or you can do high, which is getting a handle on the pin with the pin activated. So that said, let's jump in here and we'll start passing in some arguments. So what I'm going to do is I'm going to make use of a static method on this class Raspy pin, and I'm going to request GPIO 01. That means I want pin number 1 on the GPIO array. I'm going to give it a name, a very simple name of my LED. So that's a string. And then last, I'm going to indicate that the pin state that I want is low. So here's what I've got. I'm saying go ahead and make use of this method on the GPIO controller called provision digital output pin. Pass it 3 arguments. The arguments that it's expecting are the actual pin that I want, which is pin number 1, which I indicate by calling this static pointer here on Raspy pin. I give it a string name of my LED and a pin state of low. That means I want to get a handle on this pin, and I want to make sure that when I do, its default state is to be turned off. Now that's great. The problem is that you can only get a single instance of a pin in a given application. And what we want is we want this application to always be running so that we can consistently turn this pin on and off. If I consistently go back to the GPI controller every time we light, or every time we receive a light request, then it's going to error out on us. It's going to say, no, you've already got that pin initialized. You can't ask for it again. We don't want to do that. So let's do this. We're going to take this and we're going to copy it. And we're going to put it up here. And we're going to make this a private static member of this class. I'll go ahead and paste that in. So now pin is a private static member of the LED controller class. And by default, it'll be null. So what I'm going to do is I'm going to say if pin is actually equal to null, then we want to do some stuff. I'll take this, and what I'll do is I'll move it. I'll cut that right out, and I'll put that right here. The only thing I'm going to change is this. We're going to say if pin is null, pin being the reference on this static member of the class, if it's null, then go ahead and reach into the GPIO factory and get an instance of it and grab that GPIO controller. Then set this static member of pin to pin number 1 and set that pin state to low. And that's it. So I will, okay, so that's it. That's going to return the pin. And then from that point, what we do is we say, go ahead then and grab pin and toggle it. Very simple. Let me go ahead and create this request mapping, of course. And I'll make sure that we're using an endpoint of /light. And that's that. Now, looks like I've got some sort of an error here. Let me just make sure. I do. I have to return a string response, which is what it's expecting. So I'll just make that something very simple like OK. And that's it. So what I've got is I've got my very simple endpoint that will indicate to me that my application is running. And then I've got another very simple endpoint that will first say, hey, did we already initialize the pin that we're expecting to use? If we did not, then go and reach into the factory, grab that controller, and then with the controller, initialize pin number 1, and you're good to go. Once the pin is initialized, that's when this pin toggle is going to be okay. So in a case where we've actually already initialized the pin because we've had a request, it's going to ignore this part here. It's going to go right here and go into the toggle. And then that light should turn on. So there's one more thing that we need to do, or at least that I need to do, before I can kick this application off. Let me do that now. In my particular case, I want to make sure that my application is running on a different port. We're embedding Tomcat into this application so that we can accept web requests. But I don't want it to run on port 8080. So I'm going to create in the source main resources directory of my project, I'm going to create application.properties. And the nice thing is that the application knows to look for this particular file if you have any changes or any exceptions that you want to account for. So what I'm going to do is I'm going to just indicate that I want a different server port, and we'll call it 9898. And I'll save that. So this just means, hey, instead of starting up on the typical port 8080, go ahead and instead start up on port 9898. And the only reason I'm doing that is just to make sure that if I've got anything else running, I can't recall whether or not I do. I think I might. In the event that I do, this will just avoid any conflicts. So it's something that I'm doing that I'm comfortable with in my environment. It's not something that's required for you. You just, if you're not going to do this, you need to know that you need to be looking for your application on port 8080. So that's it. Now the only other thing that I want to do, I'm going to go to my command prompt here. I'm going to just make sure that I've got Pi4LED here, and I do. So let me clear that and just make sure I've got an application. And it does appear that that's what I have got. So what I want to do is go ahead and add this to GitHub. GitHub is going to enable me to not only share this code with you, but it's also going to give me a really kind of easy way to check out the code on the Raspberry Pi. So I'll get started with that immediately. Okay, I've gone ahead and I've submitted my code up to GitHub, and that's going to help me actually check that code out on the Raspberry Pi, which is up and running right now. I showed you a picture of it earlier. That thing is still humming along. It's got the circuit set up on the breadboard. It is ready to go. It wants some code. It wants to work. So what we're going to do is we're going to remote in to the Raspberry Pi. I don't have a keyboard. I don't have a monitor hooked up to it. It's just online, and it's on my network right now. We're going to access it through the IP address. I'm going to secure shell into it using the IP address and my username and password, and then eventually we'll use that same internal IP address to make web requests to the endpoints that we've just created to first test to see that the application is up and running, and then go ahead and start turning that light on and off. So I'll go ahead and make use of my SSH command. I will first indicate my username, and then I will reference my internal IP address, which is 192.168.1.84, I think. And we'll soon know, as it is. Plug in my password, and I should be good to go. I will look around and see where I am. I'm in my home directory. That's fine. Let's see. Looks like I have a projects directory, but what I'm going to do is I'm going to create a new directory, and I'm going to call this, we'll call it testing, and I'll move in there. And then that's where I'm going to check out my code. So I've just submitted it to GitHub. I know it's there. I should just be able to do a git clone and then the specific checkout address, which I will share with you in my video description. That is this. I should just be able to go ahead and git clone and grab it. I'm not sure if it's going to prompt me for credentials. It is not. Yeah, it's a public repository, so it shouldn't. That's fine. And then when I go ahead and look at what I've got, I actually now have a Pi4LED project checked out. So I'll move into that directory, and we'll see what we've got. We've got my POM. We've got my source directory. I should see main. I should see Java. And I should see COM. Zonkware. And Pi4LED, which I do. And I've got my application.java class there. I've got my controller. That's terrific. So let me go back to home and into my testing directory that I just created, back into my Pi4LED. And this is what I'll want to do. I need to go ahead and actually build the Maven package. I'll do that now. I am running Maven. And I do have another video where I actually show you how to install Maven on the Raspberry Pi. It's important that you have a look at that since we are using Maven to build this project. So what I'll do is I'll reference that video in the video description below. And if I can put it up on the screen, then you should see some sort of an annotation or something like that if you're looking at this on your browser. If not, if you're on a mobile device or if you're looking at it elsewhere, go ahead and make sure you take a look at those video descriptions to get the link to the video from getting Maven on the Raspberry Pi, because you'll need that here. And what I'm going to do is I'm just going to go ahead and run Maven package. That's going to take a little bit. This is going to take the source code that we've just downloaded from GitHub, and it's going to identify all of the dependencies. That's going to include everything that it needs for Spring Boot, and that's going to include the actual Pi4J framework that we're using to write Java code to access the GPIO on the Raspberry Pi. And it's a little bit slow on the Raspberry Pi. It might take a little bit. It won't take too long. It's going to take a couple of minutes, but it won't take forever. But what you'll see is that the Maven builder begins to download all of the dependencies that it needs. It's going to reach into the project and identify all those, and then it begins to download all of them from the Maven Central repository. So that takes a few minutes. I'll go ahead and fast track it in this video, and then we'll pick it up when it's ready. All right, and once Maven is done completing the build, then you're ready to go. I've done a directory listing here, and I see that I now have the target directory. That's a good sign. That means Maven did what I was expecting it to do. It built my application, and it's created a jar in this target directory. That's terrific. So the one thing that I need to know, this is very important, is if you're going to run an application that's using Pi4J and you intend to access the GPIO pins on your Raspberry Pi board, then you need to make sure that your application is running as root. It's kind of a bummer. I don't know why it's like that. I know that other people have kind of talked about this, and it's a bit of a complaint that's out there. And I'm not sure if it's limited to just using Pi4J, because that's all I've ever used. but it does exist, so you do need to make sure that before you run the application, you do it like this. We're using the sudo command to start up the application. So I'll just go ahead and call Java, and we'll indicate that we want to go ahead and start up a jar. That jar exists in my target directory, and it is named after my project. So that's the version that was set in the POM, which is 1.0-snapshot, and that's my jar. So what I'll do is I'll go ahead and start that up. I'm starting it up as root. And if you've used Spring Boot before, you've run another Spring Boot application and you're used to seeing it fire up on the command line super quick, just know that you are on a Raspberry Pi. It's going to take a little bit of time. It is not super quick. So what we'll do is we'll go ahead and let that run. It'll take a few minutes, and then when we're good to go, we'll start testing what we've got. We'll keep an eye on the Raspberry Pi as well, and we'll see what that breadboard is doing. We want to see that LED light turn on. So we'll give it a couple minutes, and we'll come right back. Okay, with our application up and running, we should now be able to go to the browser and fire up this fire up the application rather, and actually test that initial greeting endpoint that we created. So let me go back, and we'll take a look at this one more time. And what we've got is we've got just this root method that should output hello world. That's going to indicate to us whether or not things are working. So let me jump back over to my browser. And what I'll do is I'll just go ahead and say 192.168. Let's see, port 9898. So we've got 192.168.1.84. It's my internal IP address, and we have port 9898. I'm going to hit that and see what it does for me. It may take a little bit of time initially. That's a bummer. The application has no explicit mapping for error. So I'm seeing this as a fallback. Let me go to my terminal. I see nothing here. You know, it's always a troubling thing to think that you've got everything all squared away and then you end up encountering a problem, which is what you saw. And it's really simple. What I ended up not doing was I ended up not indicating that this was a REST controller. It's a rookie mistake, terrible stuff. Anyway, what this means is I've changed my application, and that's going to require me now to go back in and update it in Git. I have to then pull down the revised code onto my Raspberry Pi and recompile it and get that working again. So let me show you what to do in the event of a mistake. It's bound to happen. I've gone ahead, I've changed my code. I'm going to go to my command line now. I'll open up a new tab, and let's see where I am. So I should actually see some changes here, and I do. I'm going to go ahead and git add this file. I'm going to commit it and say oops. Oh, git commit oops. And that's that. I'll go ahead and push that change. And that's done. Over on the Raspberry Pi now, what I'll do is I'll stop my application like so. That's Control C. And then I will git pull. That'll pull in my change, which it did. I will rebuild my project with Maven package. And with that now rebuilt, I will go ahead and I'll restart the application again, starting it as root using the sudo command. And I will just reference my jar, and we'll kick that off. Hopefully this time things will work. Now, any normal human being who's putting together a tutorial like this would first start up their application and test it to make sure that it works so that things could go smoothly for the rest of the tutorial. Yeah, I'm not going to do that. You'd think I'd learn my lesson, but I just don't. So let's go ahead and see if it works this time. We'll fast track it, we'll get it up there, and then we'll try that greeting endpoint and see if it works. The application's now started up, and it started up on port 9898, and I feel a little bit more hopeful this time because as I'm looking at the console while the application loads up, I actually do see that two endpoints appear to be mapped that we know that we developed. The first is the root one that's going to actually be our hello world greeting, and then the other one is this /light endpoint as well. So the fact that I see them in the console brings me a little bit more hope. I think it's going to go a little bit more smoothly this time. Let's go ahead and try it. And of course, the first time you hit this application on the Raspberry Pi, it's going to be a little bit slow when it initializes the first time. So we've got a little bit of a dramatic wait. So it's going to spin, and ideally, it should say hello world, which it does. So that is very encouraging. I think our next best move at this point is to go ahead and see if we can get that light to turn on. Let's do it. We'll go back, we'll look at the Raspberry Pi and make sure that that's still turned on. And yeah, that looks like that's still good to go. So that's good. So our next move is to go ahead and go to our browser, and we will do /light. We'll keep an eye on the Raspberry Pi. I'll hit enter now, and we should see an LED turn on if we're lucky. Oh, and we do. That is terrific. And of course, my browser comes back with the OK message, that's how we configured the endpoint. That's okay. I'll go ahead and I'll click the reset button, and what we should see is the LED light turn off, which we do. That is great. That's what we wanted to see. I'll click it again just to make sure that we're not crazy. And it is on. And I will click refresh again, and the toggle should turn it off again. And it does. Hey, I think we got it to work. That's wonderful news. So a few bumps in the road there getting this to work, but ultimately we got it to work. So there's a couple of things to be aware of. Obviously, you need to have the Pi4J project checked out in your Maven project. You have to have Maven installed. When you build your project, you have to be running it as root, which is a bit of a bummer, but it does actually work. So minus the bump in the road there with failing to actually identify it as a REST controller, you see what you need to do in the event of any sort of trouble during the course of this process is, you simply correct your code, commit it back up to your repository, check it back out on the Raspberry Pi, and then you should be able to rebuild and restart and get it going. So that's about the extent of it. Go ahead and check out some of the links that I provided in the video description that will help support what you're trying to do here, and that's going to be related to Spring Boot and Maven on the Raspberry Pi. I've got some links over to Pi4J. You'll certainly want to look at the documentation for that framework and understand the wiring diagram as well. It's very basic, but it's obviously what you need to get this application working. And then go ahead and try it yourself and let me know how it goes. Thank you so much for watching this video. If you found this video interesting, if it was inspiring to you at all to use Java to interface with your pins on the Raspberry Pi, then leave this video a like for me, and certainly do me a big favor and subscribe. I've got plenty more videos to do that are along these lines with some content that's a little bit different as well, specifically some pretty interesting retro gaming stuff that I've been doing lately. Anyway, thanks for watching, and I'll see you all in the next video.